All right, and we're live. How's it going, everybody? Thanks for tuning in. Okay, so today is the first episode where I'm going to be working on the Compose compiler. So this is like basically my everyday work. It'll be interesting. This is like pretty different content from everything else in that this isn't entirely relevant to everyone who's interested in Compose. Hey, Chris Alias, is nice to see you from yesterday. These are implementation details. This is like, if you're really curious about how Compose works, then this could be really interesting to you. And it's, I don't know. It'll be interesting to see how it goes. But I'm really excited about this project that I'm actually just now starting. So this is like, I've basically written a design document, but I haven't started coding this at all. So this is something we've been thinking about for a while. And the general idea is, so what we're calling this is stable propagation and stable inference. It's sort of like two features baked into one because they're heavily related to one another. And so let me try and explain. I'm going to try and do like a few minutes explaining what the goal is, so that for like future episodes, people could come back to this video and refer to it if they wanted to. So let's go ahead. I'm going to move over into VS Code here. So Compose has this notion of a type being stable. And so I can add an @stable annotation on a class here. And so this would end up being imported from like Compose runtime. And what this does is this essentially tells the Compose compiler that this is a type where if we compare it with another instance of the same type, then the result of that equals function is going to be true and it'll be meaningful, and the result of it will always be the same. And one way to think about that is like a mutable is, if an object is immutable, then it sort of obeys this property. And like real practically, what this means is that we can compare the values and then skip the execution of a composable function if all of the inputs are the same. And so you can imagine a composable function that accepts a foo. And this just does something like foo.bar, right? And let's say bar is a string. What this means, let me just remove this in the meantime. What this means is that the code that Compose will generate is something kind of like this. Foo composer right. So there's two synthetic parameters that the Compose compiler will add to example here. And one's the composer, and so this is like the runtime object that we're able to appeal to. By the way, anyone on the stream, let me know if audio is good, if the music sounds good, and if anything's hard to see or anything like that. We had some frame rate issues yesterday, and I'm hoping nothing like that happens today. But okay, so we've got example here, and the body of the function is, is still there. But essentially what we want to do is we want to get code that sort of looks like can skip execution. Okay, everything's perfect. Great. All right, great. So we kind of want to end up writing something like this. Else composer.skip, right? And so we're going to figure out how to calculate this can skip execution expression. But this is sort of like the mental model that you should have. Okay, great. Awesome. So what this basically means is that if all of the inputs to this function haven't changed, then we're saying that the compose compiler can, or the compose runtime can kind of assume that everything underneath this composable is unchanged, and that instead we're just going to call skip, and that's going to tell the runtime, okay, we'll just skip ahead to the end of this like sub hierarchy, and then continue doing whatever you're doing. And so that's sort of like the rough idea, and like an important piece of this is that we thread this composer object through to the next function. And then this is some meta, right? This changed parameter is highly related to what we're going to be working on. Sorry, you're right. We'll do that. How about that? Thank you, Tyfly. So I'm going to talk more about what this int is, but for now let's just ignore it. But so we pass in the composer to text, and that text is another composable, and so it's going to kind of do the same thing, and this composer object gets thread like all the way down. So now let's look at this, like how do we calculate this, right? And so one of the things that we're gonna do is we're gonna create like a temporary or like a local version of the changed parameter, and we call that dirty. And it's gonna start off as changed. And what we're gonna do is we're gonna say, okay, if let's see. If we don't know that foo has changed, or if we don't know that foo, if we don't know, let's just call it current state of foo. I'll explain this later. Then what we're gonna do is we're gonna say dirty, or like encode result to dirty. And all right, maybe it's like, it might be better if I just show you all what the actual code is. But basically we're gonna set dirty, and so dirty is a sorry, why the dollar prefixes? So this is my way of kind of showing that these are generated by the compiler. So these are like all synthetic things. And so I'm using dollar just because it's clear that the user couldn't actually write this. So these are synthetics. So changed here, the type of it is an int, but it's actually like a bit mask, and it's kind of a complicated bit mask. Let's look at that real quick, because I'll show you kind of the encoding of this bit mask. So this is in master of compose, and this you can find this if you want. Compose IR generation extension. This is kind of like the central entry point for the compose compiler. So this is basically an IR transform. We receive an IR module fragment, and then we can basically mutate that module fragment, and so we can transform it into a different IR tree. And that's basically how most of the Compose plugin operates, is as an IR transform. And I'm gonna go down to this one. So composable function body transformer. This is where most of this logic is held. That took longer than expected. And there's actually some comments here on up top that give you a pretty good idea of what's going on. So maybe I should actually just start here instead of in VS Code, but let's look at this. I think I talk about the encoding at some point. Okay, I guess I don't. Thanks, Vinay. Good to see you in here. So I'm just gonna collapse everything, make it easier to navigate. And so let's look at this. Basically, this this changed parameter is encoded. It's a 32-bit integer. So there's one sign bit and then 31 bits for the int. We don't mess with the sign bit just for simplicity, but what this means, so I have this like concept of slots per int, and this is basically how many, like the metadata for each parameter, how many of them can we encode in a single int. And so we end up using 2 bits per parameter, and so 2 times 15 is 30, and then we actually use that remaining 1 bit to indicate something else. It's sort of like a force update flag. And so in the way this ends up getting laid out, right? So let's just go ahead and do it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so we've got 32 bits here. And we actually take the top one, this is the like force execute bit. So that's sort of separate from all this. And then every 2 bits after that encode a single parameter. And so that ends up as 15. And so then what happens when you have 16 parameters? Well, we end up passing in 2 of these parameters to the function. So if you ended up with 15 parameters, like, you know, you had a bunch of parameters here, then there would just be a second parameter. And so you can add as many as you want. It's not a limitation. This is just how it's encoded. And this is similar actually to how default parameters are encoded in Kotlin. The only difference is that with defaults, you only need 1 bit of information, and we're encoding 2 bits. So, so that's sort of the structure of this here. And so each one of these 2 bits, the state that we encode is one of these 4 states. And what this means, so this state is about whether or not what information we know about the result of the comparison of that parameter. And so if it's static, what this means is that the compiler, you almost lost the stream. It's recorded, DevSusa, so you can always catch it later if you need to. So static, what this means is that the compose compiler has determined that the expression passed in to this parameter, it'll never change. So it's like maybe it's a constant literal, like just like 1, 2, 3 or something. If I ended up calling or like a string, so if I passed in hello world here, then what we would do is we'd pass in the composer, and then we'd pass in a constant here. So we'd pass in 1, 1, which means that this is static, and then 0, which is that force update bit. So we'd end up passing this this int, which I'm representing as binary here. So that's what static means. And the reason that we separate this into a separate state is because static is usefully different than being the same as like the previous execution, because if it's static, we don't have to check it at all. What this means is that it's like it's known at compile time that this will never ever change. So it's telling the runtime, don't even bother comparing it ever. So we don't need to waste CPU cycles for it. The next state is what we call different. And so what that means is that means we know that this value changed from the last composition. And since we know it changed, we don't have to compare it again to check whether or not it changed. And so if we ended up passing that, it's 1, 0. So if we ended up passing this to text isn't gonna bother comparing the string you passed in, because it already knows for certain that value has changed. And the important thing is that it knows, like, if it's in this state, that if it's indifferent, what it means is that for all executions, for all compositions at this point, we will know for sure what the comparison result of that parameter is. So we'll know if it's different or the same. And so we call these 2 states collectively as certain states, or well, really these 3 states. And so what that means is that we're certain of the state of the parameter at this point in the composition, and we're always going to be sure about what the state is. And what that means is that we can safely not store the value in the slot table in like the runtime cache, because we know that we'll never have to. And so that's important, because we can't know one time and then not know the next time, because if we don't know the next time, then we can't figure out whether or not it changed, because we didn't store it from the previous time. So and so these collectively are the uncertain, or are the certain states, and that means that the only other option is to be uncertain. And if we're uncertain, that means that that we need to go ahead and compare it and store it in the runtime so that we can find the result. And so we use 0, 0 for uncertain. And one of the reasons that we chose this, I mean, there's a lot of reasons for this particular bit pattern. But one of the reasons is that when we just pass in 0 here, it'll kind of just work. So 0 is like a sane default. If you like don't know what to pass in here, it's basically just telling the runtime do all of the work, and that's that. So anyway, so that is the encoding of the changed parameter currently. And so that's important to understand. And so then if we go back up, let's grab some of the other comments here. Okay, so here's like a good example of like the actual code that we generate here. So just grab this. Let's bring that over into VS Code. So this is an example of a single parameter composable function, just like we just had, where the first parameter is a stable type. So stable in this case is so we described stable before, but all of the primitive types are stable. So like int and string and stuff like that, even though they're not annotated as that. So then let's walk through like what this is doing. We're creating this temporary dirty variable, like I mentioned before. Then we say if changed and static equals 0. So this isn't really the same as static. It's the same bits, but really what this is saying is give me just the bits for that first parameter. And so this is an expression that gets the state of that first parameter. And it's saying, okay, if that state is uncertain, then do this, right? So we can replace this with if uncertain, right? And so then what we say is, okay, we're gonna set dirty to itself ORed with this expression. And so it's either going to be this or this, right? And if we look at this, then this state here, so this is the state for different. Is that right? Yeah. Else, actually, I think my example might be wrong. Hold on. Yeah, I think this is just written wrong, but anyway, I think this should be this. And this should be this. Anyway, so what this is saying is, if x is changed from the previous composition, then mark the first slot in the dirty parameter the dirty variable as dirty or as different. Otherwise, mark it as same. And so once we've made this comparison, we're now certain about the state of x, right? We now know if it changed from the previous time or not. So now what we do is we do this crazy thing, right? So this is basically our if we should execute, then execute, otherwise skip. And the way we calculate that, so one, this is we say, okay, not composer.skipping. So this is sort of like we ask the composer if it's in a state where it wants us to compose regardless. And that can happen in certain situations. I'm not going to go into which ones, but so let's just kind of ignore that. Let's pretend it's not there. I've never seen XOR being used in programming. We should look at some hash code functions have XOR, but this is yeah, this is kind of interesting. Let's just go through this, like what's happening here. This is our way of saying this is basically a way of getting, do any of these parameter slots, are any of them in the different state? Or uncertain, but if we've compared them all, then none of them should be uncertain at this point. So really we're just looking for different. And so we can like kind of look at real quick how that works. So let's just write out these different states. So we've got 0, 1, 1, 0, and 1, 1. And so this is like the state that's in the slot. And you can see that what we end up generating, this actually, I think this is wrong too. I think it should be this. I think my example's wrong. Anyway, so let's say what we're gonna do is we're gonna AND it with 0, 1. And we're gonna do that for each one, and then we're gonna XOR it with the same thing. And so one of the reasons that this is needed is because that first bit here, what we want to do, so that first bit, remember I said it's basically like a force execute. So if that first bit is 1, then we want this expression to be false, right? And so basically this int, or this mask and this mask, are going to be identical except for that first bit. So it's going to be 1 here and 0 there. And the reason is that, so if that first bit is 1 here, then the AND is going to keep it as 1. And then the XOR, it's only going to keep that 1 if this value is 0. So we use XOR. And so that means that the first bit, if it's 1, it's going to stay 1 all the way down the line, and then that'll be unequal to 0. So we can ignore that bit. And so if you ignore the first bit, these masks are the exact same. And so when we go up here, we're basically we're ANDing it with 01 and then XORing it with 01. And so let's just work through what that actually does each time. And so in this case, the AND is going to be both zeros, and then the XORed with zeros, we're going to get just the same thing, right? So and then this one, so the AND is going to end up with 01, and then the XOR will get rid of it, so then we'll have 0, 0. And then this one, the AND is gonna end up with 0, And so let's see. Yeah, so that'll be 0. And then this, what was your experience with compilers prior to starting working on Compose? It's a great question. I had very little experience working with compilers prior to Compose. Most of my experience, I mean, I have a lot of experience related to UI toolkits, but not related to compilers. And so this was one of the reasons I was really excited. One of the reasons I found this job to be really exciting was because it was one of these unique opportunities where I could switch to doing something that was both super new to me. So I was like learning a lot and challenging myself with new things, while at the same time leveraging my experience and like providing value to the project. And I guess my advice to people is if you ever find the opportunity to do something like that, to do it, because I think once you spend a bit of time as a software engineer, like there's a way for your career to progress, and you to get sort of more and more experience and knowledge in a given area, to where it becomes impractical for you to move away from that area. And so it's sort of like you get stuck in a particular niche of expertise, and that's like fine. Yeah, I mean, like if you really enjoy doing that, and it's like you provide more value to the company and stuff like that. But if you start getting paid more and more, it becomes sort of unfair to a company to pay you the same amount if you like are doing something completely new and completely, you like sort of become a junior developer or something again in that area of expertise. And so I just found this opportunity to be really, really cool, because I was able to provide value, leveraging my expertise, while also like jumping into a whole new world of like compilers and sort of being really new at that. So anyway, that's like sort of a brief side. Is good question, but very little experience with compilers prior to this. Yeah. Thanks for the question, Joe. So back here, we're in here. So this will end up being 0, right? Because yeah, this ends up being 0, and then we're XORing it, and so then this is 0, 1, and then this. 1 and 1, 1 and 1. So this ends up being 1 XORed. We get 0, 0, right? So then this is the result. And so what we see here, so this is uncertain, and this is different. And so what we see is that if we get any bits in the result of this expression, in other words, if it's anything but 0, then we need to execute the body of the function. And so that's where this like gnarly XOR expression comes from. It's just, some sort of crafted bitwise logic to be able to just compare to 0 and have that be the thing that we want. And that's basically it. So that's how we calculate this expression here. And our current project, will you have a dirty flag per argument? No. So that's why it's a bit mask. So we will have one dirty flag or one changed argument per 15 parameters. So if your composable function is 15 parameters or less, it just is represented as a single int. And processors are really good at doing bit manipulation with ints. It ends up being, you know, very cheap instructions, and so it's one of the reasons that we did that. Okay, so to summarize the sort of current project, or the thing that we're gonna work on, is basically we're gonna change this encoding to where instead of 2 bits per, let me actually bring this back up. So instead of 2 bits per parameter, we're gonna add a 3rd bit. And that means that we're no longer gonna be able to fit 15 parameters into one int. You know, it'll be more like 10. What font am I using? Good question. This is the Dink Mono font. Let me bring it up. This is made by Phil Pluckthune. I don't know how to pronounce his last name. He actually just announced last week that he's gonna stop iterating on this font. And so he's now providing it, I think, at a discount, but it's sort of locked now. But I supported him. He works at Formidable Labs, and I just thought it was a really nice font. It has some nice qualities to it. Like one of the things is if you have a lambda parameter, it's got ligatures and everything for the arrows, and oops. It also, as you all have probably noticed, like it sort of does like these ligatures for not equals and stuff like that. I've not tried JetBrains Mono. I'll check it out though. I don't know. Let me see. What is this? Brains Mono. Does it come with an IntelliJ or something? JetBrains. Nice. Yeah, looks good. Might check it out. Thanks. What would the 3rd bit be used for? Yeah, the F ligatures are nice for function and stuff. So yeah, so what the 3rd bit, what we're gonna use it for is to encode whether or not the type of that parameter is stable or not. And not really actually even the type at this point. It's really about whether or not the expression of that parameter, like so the value of that parameter is stable. And so I'll explain a little more about that. But so what we're gonna do is we're gonna add a bit to each one of these, and for the most part this will all stay the same. So let me see if I'm not able to. So this will basically all stay the same, but now we have 3 bits, so we have more states that we can encode. But basically what the only additional state that we really care about is like this one. So basically we have uncertain and stable, and uncertain not stable, right? And then all of these we can assume are, you know, same, stable, different, and stable. Like if the type isn't stable, then compose really can't do much about it. It's like it's not at that point, we can't make any optimizations around the type, so we just pass it through. So technically with 3 bits, we have 8 states, but really we only care about these 5. And so we're now encoding extra information into uncertain, basically. And so what this means, this is basically what we have today, which is uncertain and stable. But this is sort of this extra information. It's like, okay, this is unstable. Hold on 1 second. So is it to know if you need to run the first or second part of an inlined lambda? Lewis, I'm not sure what you mean by that. This doesn't have too much to do with inline lambdas. It's more to do about with whether or not we want to run this comparison. Wouldn't it be a 4th bit? No, it'll so basically it's just it's a binary state here. So it's either inferred as stable or not. And that's kind of all we care about. So we're sort of encoding both the comparison state, which is the same or different, and then the stable state. And so what we're gonna end up choosing here is for 0 to indicate stability, and 1 to indicate unstable. So sorry. So basically these will end up being the 5 states. And then the neat thing here is that we can actually do this. So 1, 2, 3, 4. Guess I was wrong here. We can do that. And then this ends up being being this basically. Is that right? Let me make sure. So that's 1, and then XORed with 1 and 0. Yeah. Yeah, I think this is right. So we basically keep our, or no, we want unstable to produce 1 here. Oh, so I think, yeah, okay. So the trick is that this ends up being 0. So if the expression that we use is basically 101 here and 001 here, then being unstable ends up producing bits in our result, which means that we would have to execute because it would be not equal to 0. And so this is going to be our new binary representation for the changed bit mask. And I'll start explaining a little bit as to like why we're going through all this, and some of the cool things that we can do as a result. At which point of the execution do these flags get created to get passed into the function? That's a good question. So like everything's at compile time. We like basically all of these values end up coming essentially from compile time constants either here. So when you call composer.changed in the generated code, we're setting these bits to either different or same. And then also at the call site. So if we did like text and we passed in x, right? So let's say that x is a string. And so then we have this parameter for this function that we're passing through into the text composable. What we can do is when we pass in the composer, but we can also pass in dirty and 110, right? So we're basically saying take the bits from dirty in the first slot and then pass it into text. And so this is saying whatever information we know about x, it's going to be the same for the first parameter in text, whatever it's called, whether it's value or text or whatever. And so we pass values in that way. And then similarly, like if there's something that we can infer from the expression itself, so like if it's a string constant, then we know that it's static, so we can pass in static for that parameter. And then there's other neat things that we can do as well. Like for instance, we can, so if let's see, like this is a poor example, but there are certain, a better example is like 10 plus, or like let's just do this. So 10.dp, right? This is a value you might pass into a composable function, like in a lot of cases where 10.dp, it's not a constant expression because you're passing a constant into a function. This is similar to like, it's similar to passing 10 into a dp function, right? So we have this. So there's some dp extension. It's really an extension property on int, and what we can do is we can give a hint to the compiler that this is actually a stable expression or a stable function. So what that means is that if the inputs to that function are static, then the result is also static. And so what the compiler ends up knowing is that when you say 10.dp, we actually pass in a bit mask like this that says, okay, that first argument is static. It's never the semantic value of that expression is never going to change. And so we can do some clever things like that. Is there an algorithm to know which compose functions need to update the state, or just compose use that bit logic? I don't know which. So Jorge, I'm not sure if that's the part of your name, but so is there an algorithm to know which compose functions need to update the state, or just compose use that bits logic? I think I'm not entirely sure what you're asking, but I'm going to try and answer it. So like basically, when you read a state variable or a state object in a composable function, then the scope of that function essentially gets subscribed to that state object. And this happens if you like go and look up snapshot mutable state. See, I can pull it up. So snapshot. Here. So mutable state. If you go and look up here and you kind of follow the long path here, when you read a value of a state object, you end up calling this, and one side effect of calling this getter is that the current scope will get subscribed, and then likewise when you write to something, it will invalidate that scope, and so that's how that works. And so it's not super related to this bitwise logic that we're talking about here, but I'm not sure if that answers your question or not. Let's see. So that's what stable means. What of immutable? Yeah, so that's what stable means. Good question about immutable. Immutable and stable are very similar. So they do the same thing in terms of what the compiler says. They contractually are slightly different, but basically immutable is kind of that's the most common form of a stable type. And so the contract of a type being stable happens to be a contract that an immutable type would satisfy. And because immutability is a much more familiar concept to people, we gave a sort of specific annotation for it, because I think it's easier to sort of understand and reason about. But in the eyes of the compiler, the hint is sort of the same. And the way that works, there's a stable marker annotation, which is an annotation, and then we have the stable annotation, which is marked as a stable marker, and then we have the immutable annotation, which is also marked as a stable annotation. So if you have some annotation that is different than stable and immutable but satisfies the same constraints, you could annotate that annotation with this, and then the compose compiler would do the right thing. Follow-up. So the main performance advantage during runtime comes from the advantage that the knowledge of a changed parameter can be passed down the hierarchy. Is that correct? Yeah, I don't know if I would call it the main advantage, but that is one advantage to this strategy, is that if, like, so in the case where we're passing X here, right? If we spend the time comparing the string here, so we'll call composer.changed on it, and that's going to end up calling dot equals on this string. And I mean, if it's a big string, it could be expensive, but like regardless of what type of object it is like, depending on the equals implementation, that could be a costly, it uses CPU. And so if we're gonna do it again, like we already have the result, so being able to pass that through is valuable, especially in a case like this, where if, like, let's say this function has like a bunch of parameters, well, so maybe it doesn't get skipped because not all of them are going to be the same. But then you just pass one of them into text. Well, if the string itself hasn't changed, then text just gets skipped, and it doesn't have to do anything. And so it's useful to be able to pick out the information just for these individual parameters. Add immutable is treated identically to stable by the compiler. Oh, sorry, that's Chuck answering the question. Thanks, Chuck. Do we expect app developers to annotate their own code with that stable? If so, what would be a common case? So that's a great question, Joe. The project that we're working on is basically to avoid that. One of the things I don't want to happen is I don't want like the entire Android ecosystem to just go and start annotating all their classes as stable or immutable or whatever, because, well, one, the constraints are maybe difficult to understand by some people, especially for stable, but like even immutable, a lot of people mistake immutable for read only, and they're not the same thing. And also, this is like a compose specific annotation. I don't really want like, you know, this like these composed annotations to be sprinkled all over the ecosystem, and so this is sort of a situation that I'm trying to avoid, and this project is an effort to do that. And so basically we're going to start trying to infer whether or not a type is stable, and we haven't done that previously because it's a little bit dangerous, because if we start inferring it, then maybe a type accidentally was stable and then like later didn't become stable. Like you changed an implementation, and so we want to make sure that whether a type is stable or not doesn't end up being part of your public contract, if that makes sense, unless you annotate it as stable. Okay, so Chuck basically said that. I should read ahead and see how Chuck has helped me out with the answers here. Finally, I can understand what stable and immutable are. Yeah. I'm still lost, but this is very interesting. Well, thanks, Danny. I'm glad this is interesting. Let me know if there's, if you have specific questions. Let me know. I'm happy to try and explain better. Okay. So let's talk about why this is useful in some cases, right? So let's just get rid of some of this. Let's say we have a composable function. My let's call it my recycler view. And so it accepts a list of some type, right? So at the moment, if you write a composable function like this, this function can never skip, right? Because as soon as you put in list here, list is an interface, and implementations of that interface can be super mutable. Array list is a very mutable type, and so its value can change over time, and so we don't know that the result of equals will be consistent. So that's kind of a bummer, right? Like just by having this parameter here, I've lost the ability for this composable to skip. Now, other composables that I call underneath, like my children, those can still skip depending on what their parameters are. But like, let's just focus on this function here. If I've got my app, and I call recycler view, and like, let's just say I pass in, A, B, C, right? There's a lot more information that we have here at the call site about the stability of that argument than we have here in the function. Here, all we know is that it's a list of some type T, right? But here we know that it's the result of a list of call, and so we might know that list of returns a list implementation that is immutable. And then more than that, we know the type of the elements of that list. So we know that those are strings, and so we know that those are stable. And so we can actually treat this argument as stable here. And more than that, actually, in this particular case, we could treat it as static. but we need to pass that information in, because you could also you could do something else, right? Foo val bar, it's right. I could do this. Right? And now all of a sudden, the same function, the same composable, is getting an argument that is very, very unstable, right? The list itself is mutable, but also each one of the items have mutable properties on it. And so we need to somehow handle, in the implementation of this function, we need to handle both cases. And that's the big deal. And so we have much more information at the call site, but if we're going to do this safely, we need to handle both cases in the function body. And so the way we're going to do that is by encoding that information in the changed parameter, and then using it in the body of this function to do one thing or the other. Let me read some comments here. Yeah, it makes sense. Definitely don't want junior engineers to have to ask themselves if something is stable or not every time. Personally, haven't found a use case for it yet anyways. Yeah, I mean, so we've kind of intentionally tried to not talk too much about these annotations. I don't want people to worry too much about them, and I hope that is kind of how it stays. Like we want people to we want to have the compose compiler optimize around like good typical code patterns. And so if I write like a nice clean data class in Kotlin with all vals and like, you know, all that, we want the compose compiler to be able to take advantage of that. And we don't want people to have to know about all of these implementation details of compose in order to ensure that like what they're doing is the right thing. And so even if the type you write isn't stable and like, but it like almost is or something like that, like I don't really want too many people to worry about this. I want to make the compose compiler good enough so that it does the right thing a high enough percentage of the time that like this usually just doesn't have to be worried about. I mean, like maybe, you know, some it's good to worry about this like if you're writing, you know, some very cross-cutting library or something the impact of you understanding those implementation details is going to be far-reaching. But for the most part, I want the compiler to do the work for you. Lewis asks, isn't it dangerous regarding binary compatibility to infer non-explicit stability? Well, so there are some things that are important. Like, so binary compatibility, not so much. So we're going to do this in a way where the binary, I'll talk about how we're going to do this, but we'll do this in a way where the binary compatibility is unaffected. But you are correct in that this will basically what doing this would mean is if your type goes from stable to unstable, like you add a mutable property or something, then some composable function somewhere that uses that type might stop skipping because that type is no longer inferred as stable. But this is not a binary incompatibility. This is a behavioral change, but you changed the class. So a behavior change here, I would say is like warranted, justified, expected. So it's not really a binary compatibility issue, but what it means is that just like a number of other things, the meaning of the composable hierarchy won't change, but some optimizations might be lost. And that's true for pretty much all compiler optimizations. Hi from Iran. Yeah. What font is that? It's Dankamano. We some earlier people asked earlier, but it's the Dankamano font. Shouldn't Kotlin just give us an immutable modifier to allow to commit a part of an API to that? Yeah, I think that would be great. If Kotlin had some way of indicating that a type was immutable, and that was part of the public contract, then that would be great, and the Compose compiler would definitely start using that. I think that the Kotlin team is interested in some notion of immutability, but they want to do it the right way, and they also have a high bar for JVM interop that is going to make this a lot harder. So some of this might depend on like what sort of features Java adds to the language and stuff like that. One thing that I noticed myself doing, I tend to add logs in composable functions to check when, how often they're getting called. Is there a better tool or strategy to understand how your composable tree is behaving when changing an input? Joe, that's a great question. Basically the answer is now there's not a lot to help you, other than what you're probably already doing. But this type of introspection into the current composition and like what's recomposing and how often and what's skipping, these are things that we want to add tools to Android Studio to help you understand that. Let's see. Isn't stable similar to deterministic? I'm not sure they're the same thing. I think deterministic seems like a broader statement, but what it means is that it does say something about the determinism of certain properties and functions, and yeah. So I think that's a good way to look at it. Yeah. Let's see. I was thinking library A using previously stable from library B in a composable would break. Yeah, so Lewis, I'm going to talk about exactly how we're going to implement this, but we're going to implement this in a way where it would not break. So that the problem you're getting at is essentially the reason why we haven't done this yet. And the strategy here is going to get around that issue. I feel like the community could build a handy visualizer for this. So yeah, totally. I would love to see some members of the community building tooling around Compose. I think that'd be great. So I also want to see Google do a lot more around tooling in Android Studio and stuff for Compose. So hopefully we'll see that as well. Okay. Let me get back to code here. So, IntelliJ Babel, you have transcodes now. Oh, Joe, that's great. Thank you. That doesn't. So I'm not an affiliate though, right? Or am I? I don't know. Either way, that's great news. I was just right after I started the stream today. I had just remembered that I was going to change the the downsampling to be 720p, and I forgot to do it, and I felt bad. But so that's great news. So thank you, Joe. Okay, so let's talk about what Lewis was asking about, because there is a binary compatibility question here. Okay, great. Well, I don't know if that's partly you're doing or just the way the system works, but if it is, thank you very much. Appreciate that. Okay, so we've got foo here, and like let's say that this is a type that we can infer as stable. So here it's immutable, and so this is something that we could infer as stable. What we kind of want to do is something kind of like this. Stability. So what we're probably going to do is something like this. And this will end up like for a given type, what the compose compiler will do is it will essentially add a static final int onto the generated class, and it'll be synthetic, and so it won't be visible to the IDE or anything like that, and this will basically be a value that'll indicate some stability, right? So like let's just call it stable, and then so the way this will work is in this case, so we would know that mutable list of is never going to return a stable type, so we wouldn't generate anything in this case. But let's say this is list of, right? So we know that the stability of the expression returned by list of is going to be stable if the type T is stable of that list. So what we would end up doing is we'd like pass in the composer, and then here we would basically say, you know, foo.stable, and then that would end up passing the state of, or the stability of that first parameter would be encoded in the changed int here, and we would do that using this static field here. What if foo comes from a compiled library? It's a good question. So we're gonna get to that. So we're only gonna generate this code if this property is there. And so if foo was compiled by a library that didn't use the compose compiler as part of it, so this is in like, you know, some external library, then this stable int won't be there, and in this case we've basically lost the optimization, and so the stability of foo can't really be known at that time, and so we still want to give people the capability of indicating that foo is stable, even if it's from a library that they don't control. And so what we're probably going to do is that there will be some compiler argument that you can provide, or some configuration file that you can provide, that will tell the compose compiler while it's compiling app it'll tell it consider foo to be stable. And in that case, if it did, then what it would just do is it would pass in this value, right? And so because at that point it knows that foo is considered stable, at least for that compilation unit, it knows that foo should be considered stable, and so it would pass this in to do that. So let's see here. Immutable data class foo. Yeah, I mean, if Kotlin had a keyword or something like that you could reliably look for, that would be great, and we want them to go down that path, but that's not going to happen anytime soon. Okay. So I think at this point this is a pretty good primer for like the goal, the scope of the project and what we're gonna do. So I think we're ready to just start coding, basically. Right? So for anyone that like is gonna ask in the future kind of like what I'm working on and what any of this means, I might refer to this video to sort of gain that context. Let's see, what is Tim asks, do you think these kinds of optimizations will be needed to get a decent performance in a regular use case? I mean, it's sort of a hard question to answer. Like I think, I mean, so right now we don't have any of these optimizations, and we're seeing pretty reasonable performance. But like we're also seeing that there's ways, especially if you know, you're doing some animations that are causing big sections of your composable hierarchy to recompose, that there's a lot of opportunity for skipping that we're not getting because certain types aren't marked as stable. And these types might be like stable. It's just this is userland code where people aren't annotating things as stable and stuff like that. You could add some checks for class immutability and compiler plugin though. Oh, is that Andrei Shikov? Nice to see you. So we are gonna do that. I'm not sure if that's what you're getting at or not, but what we're going to be doing is we're going to be looking at we're going to be looking at classes in the compilation unit, and we're going to be adding these stable markers for when we can determine that they are stable, and so then we'll be able to leverage that. But for modules that are not being compiled by the Compose compiler, there's really no inference that we can do, and so at that point, we would have to default to uncertain or unstable, and we'd rely on people passing in configuration if they want to make sure that that type is considered stable. Okay, let's do some code. So here we are. This is our, like I mentioned before, this is the sort of entry point to all of the Compose IR transforms. So I think what I'm gonna do is I'm gonna add a new transform here. So let's see. I'm just gonna let's just create a new file here. Let's call this stability class stability transformer. And I'm gonna make this implement the abstract compose lowering, which is just, it has some compose specific helpers that we've added over time. Let me just go. Just gonna steal this. All right. Let's see. Flutter is very fast for hot reload. Just press Command S and app updates right away. We're looking, same for compose. Is there anyone working on that? Yes. Yeah, I mean, this is something that we're working on. It's definitely going to be better than it is. I'm not sure that compose will ever be able to have the reload performance that Flutter has, because you know, the Dart VM is really optimized for this, and so this is one of the things that Flutter takes advantage of. But it is something that I do think we can get much better than we are right now, and that's something that we're working on. Do I get access to the full Kotlin standard lib and compiler plugins? What about external deps? I'm not sure what you're asking. So we're in the compiler plugin, we're writing this in Kotlin, but I'm not sure if that answers your question. We don't have, like, so when we're transforming IR, if the code, like, we see the current compilation unit, which is like the classes that you're compiling, and then if they reference methods or anything from external dependencies or standard lib or anything like that, then we see those as like external IR stubs. And so we have some information, but not a ton, but we know where it comes from and stuff like that. Hey Dustin, good to see you. If it was me, I'd be having nervous breakdowns. Yeah, hopefully I don't have any of those. So there's no restrictions in what you can write inside a compiler plugin. Okay, I think I see what you're asking. So, like, can I generate code that references, like, or generates like arbitrary code? And the answer is yes. You can essentially reference anything on the class path, but you have to kind of know how to get it and stuff like that. So that can be difficult. But okay, so let's do this. This is what I actually wanted. All right, I'm gonna get rid of that. And file lowering pass makes sense. I think actually we could make this a class lowering pass, yeah. Since what we're doing is just working on specific classes, like basically this transform here, it's basically going to be adding that we're gonna want it to analyze the body of a class, like the implementation, and then we're gonna add this stable property on it. and decide which value we should give it. And so really the only thing we're focused on is that class itself. And so that means that I'm just going to implement it as a class lowering. Well, actually, I think the way that we do our plugin, it'll end up being module. But anyway, it's fine. We'll do it. It won't really change the way this class looks. So let's see. So the abstract compose lowering implements a IR element transformer. And what this is, this sort of implements the visitor pattern. And so what I have here is like all of these visit calls. Oh, you don't see them because of the autocomplete. But so let's say and fun visit file, or let's say visit class. So this is one of the overrides, but this visitor function, it takes in an IR class, and I just need to return an IR statement, but I'll probably be returning the class itself. But what I can do in here is transform the class if I want to. So Danny says, I guess it's more flexible than an annotation processor. There you can only create new code, not rewrite. Yes, that's definitely true. Here we're really transforming the code that we write. And so in that way, it's much more powerful. The fact that foo is used by compose adds the stability constant would cross compatibility. Yeah. So Liz, this is a good point. This is something that I was a little bit concerned about, but I think this is justifiable. So at the end of the day, if you add in the compose plugin, compose compiler plugin, we change some code. So like if you have a composable function, we change the signature of that function, and so it changes the ABI of that module a little bit, right? And this creates a new case where that happens, and I think that should be done with a lot of care. But I think that this is worth it, and I think that it's not manipulating the binary signature. So this is a synthetic hidden constant, and so the only time that you're going to get some sort of issue is if some compose module is running against this jar that used to be compiled by compose and is now not compiled by compose. But the fix there is to just recompile the jar with the composable, and this I think is an okay trade-off. What is stopping me from writing a compiler plugin that uploads your code to a server? Does the code generation remotely, then receive that result back locally and produce the final code? I mean, you could do that. You might run into, I mean, it might be difficult because the IR isn't completely serializable. You can serialize like a representation of it, but a lot of things are used by reference. And so it might be, this definitely sounds possible, but I think you might have some challenges making it work. But totally a thing you could try out if you wanted to. Kind of reminds me of the closure compiler for JavaScript. Okay. So what I'm gonna do is I'm just gonna start writing. I'm gonna try and get a test pipeline set up for this, so that I can start seeing what the output of this is, and I don't want to do too much without that. So let's see. I'm gonna literal. Here's a similar test file that I'm just gonna copy and start from that. So and we call this class stability transform tests. So we have this abstract IR transform test that we created, and I get a module fragment and generator context and stuff like that, and live literal transformer. Okay, so basically this transformer, I'm gonna create one of these class stability transformers, and gonna be able to pass in the plugin context, the symbol remapper, and the binding trace. And then we just call lower on the entire module. And then that'll return, well, actually it won't return anything, but the module is then transformed. And so this test then will take the transformed IR, and it'll let us print some stuff out. So let me show you how that would work. This is basically what we want. We can get rid of all this. And so we can have this assert transform method. And then what this allows us to do is it allows us to basically pass in some source code as a string. And then it sort of prints out what the transformed code looks like. So I'm just gonna have it. I don't want it to. Because it doesn't really have anything to do with composable. So I'm just gonna put that there. Expect transformed. What's the signature of this? Source. Expected and then extra. Okay. Source expected and then unchecked, I guess, is what we pass in here. Okay. This is sort of a useless method now. It's just passing everything into here, but I'm gonna keep it just because I might change some things later on. And so we'll just have this little helper method locally in this class in case we need it. Let me see what the comments are like. So Lewis says, if the stability metadata is not a constant but a val with a getter, I think it could work across compilation units. I don't think that makes a difference here. At the end of the day, it's you're linking against a method or a field that may or may not be there depending on whether or not it was compiled with the compose compiler. So I don't think that that would change anything meaningfully. And in any event, I want it to be a static final int so that R8 can inline and constant fold these things. So I don't know. I don't think it's any different, but let me know if you think it is. Let's see. So let's just build a first test. Test empty class, right? So this would be a good test case, I guess. So we can start off with, let's see, what's the, so unchecked, checked. I think it'll be common for me to not do anything here. So I'm just gonna do that. I think often I'm just gonna have these two. So, so let's just say class foo. And then the results here that we're looking at is basically going to be something kind of like this. That's annoying. So it's an empty class, but we're going to be generating a constant. So I'm not sure how it prints out static final ints, but let's just oh, and the other thing is I flip out $signs for percent signs in here, just because it's really annoying to have a $sign in the source code because of Kotlin string interpolation. So the percents are just find replaced. But so let's say, okay, stable int, and this should be, let's see, stable. For stable, we use 0. So actually, this will just be 0. Because we want this to be stable, which it's maybe a little bit unfortunate that 0 means stable and not unstable, but I don't know. I'll have to think about that. I think that's okay. Constants are inlined, hence the difference. So Lewis, I'm going to be trying to do this in a way to where constants are not, or this constant will not be inlined by the Kotlin compiler, but it will be inlined by the R8 compiler, precisely for this reason. So okay, let's just go ahead and run that. It won't produce this right now, but that'll be just help us with our test case. So we've got our test set up now. So let's go ahead and try and do something. I think what I'm gonna do first is just try and add the constant onto the class, just so we can get that set up, and then we'll figure out how to add the right constant onto the class. But just adding a constant at first seems like a reasonable thing. So what this does is this just calls the visitor pattern on the module fragment with this visitor. And so what I want to do is first, so run everything, like visit the actual class, and after it's visited, everything will be transformed by this transformer, and everything will have been visited. So we'll have all of the information that we need to have about this class. And then I think I can just say like result.declarations. Oh, I probably want to. It's gonna be a class, but in case it's not, I mean, just because the type system says it doesn't have to be, we can just opt out in that case. Do that in a separate line, I guess. Val class equals results as our class, or else we'll just return it. All right, and then here, I hate these Z's, so I'm just gonna like class, something like that. Declarations. So this is a mutable list of declarations here. So the result of the test came back, and you can't see the window that opened, which is kind of a bummer, but it's basically just class foo. So no constant, which is what we expected. I wonder if there's a way, compare with clipboard. Is there a way for me to have it avoid this like compare thing? I don't think so. If anyone knows, let me know. I'm not sure if there's a way for me to disable this thing for streaming. You want JVM field val stability then? Yes. I agree. Yeah, you're right. I used const in my example, but yeah, technically, I mean, at the end of the day, I'm generating JVM bytecode and not Kotlin anymore. So like the const keyword isn't exactly what I'm using, but I was using that as a way to demonstrate what I was thinking. But you're right in that we don't want the Kotlin compiler to inline this constant, or else there are some concerns for well, actually, I don't know. I'll have to think more about it. But yeah, we might go with what you're suggesting. So let's see. I'm just gonna add, and let's create like I think I can just generate an IR field here. Let me see what what that lets me do. Yeah, it lets me say is static true. So I think that's what I want. So undefined, IR declaration origin. I think defined might be fine here, but if there's some synthetic one, I might do that. Or I could try and create my own, but every time I do that, it results in like some other part of the compiler freaking out about it. So like I think making your own IR declaration origins end up being a bad idea pretty much every time. Fake override. No, it probably does something special for that. Yeah, I'm just gonna try defined. I think that might work fine. Let's see, what does it want now? Symbol, name. So I'm just gonna do symbol, and then name will be I'm gonna say name.special stable. I think I might we've got a class that has a bunch of these. So let me see. I think it's called something weird like this. Yeah, so we do like change parameter and stuff like that in here. So I'm just gonna add one of these. Val, let's see, let's call it stability. Flag maybe. I don't know. I'm not sure if that's the right name for it, but we'll just start with that. Okay. And then after name, oh, so it wants there are multiple implementations of this. So I won't have a descriptor, so I don't want that. This is basically what we want though. So symbol name type, type visibility, and then all these things. Okay. Type name and visibility. So the type is going to be an int, and so I can do context dot built-ins. Is it IR built-ins int type? And then visibility is like an enum, basically. And so we want this to be public. And I think public is fine because of the $sign, this won't show up in any autocomplete or anything like that. Alex, Command P. Okay, I actually didn't know about that. I usually use command space for control space, but seems to be underpowered. So thank you for the command P. What is this? You can use the build field method. Yeah, I'm probably gonna change it to that. I just wanted to see what IR field afforded me. So what's that shortcut to see all the params and the text? Okay, yeah, command P. So thank you, Alex, for that. Bunch of element builders for IR. Yeah. We use some of our own builders. IR fields will never show up in the autocomplete. Front end has no idea about these. Yeah, that's a good point. I was thinking that maybe in Java, it might be more confused, but maybe not. I don't know. Yeah, but I think public is what we want. Okay, so I gave the IR field symbol. Just gonna do that, and then so is final we want to be true, and then is external is static. Oh, and is static we want to set as well. Then is fake override we don't care about. So I think that's basically what we want. Wonder what it is complaining about at the moment. Oh, did we change the order? Symbol name type usability. Okay, I think it's just mad about this. All right. I don't know why. Origin. Oh, I guess is external isn't optional. False. All right, there we go. And then I need to create a symbol for this. Trying to remember how I did that. Build field. Do I need a symbol for this? So I think this will create a symbol for me. Which is great. So I think that's what I'll do. Okay. So let's try that. Add build field. just do that. So I want this to be public, and then we'll grab this for the name, and a static true, and let's see if we can set as final here, true, and then the type will be int. All right, so see how that works. So let's go ahead and run our test again, and then right, the wrap field descriptor. Yeah. Add names to arguments. No. Yeah. So Andrei Shugov is showing that he's a better engineer than me, unsurprisingly. Okay, so let me so you guys don't see, or you all don't see this window, but let me show you. So we're now adding the field to that class. Oh, sorry, the test hadn't run yet. So let's see what. Yeah, I can do that. Definitely a little cleaner. Okay, so what happens in this test is so this is the output of the printer, which I haven't given it an initializer or anything like that, so it's just a empty field right now. So I guess it's like maybe important to say, like the way this is printing out, this is using a basically a printer that I wrote that takes an IR tree and tries to print something that looks like source. And I don't think that I've ever needed to deal with static properties yet, because it's not really something that's like, I try to make it look like Kotlin. And so having just like a static field like this doesn't actually happen in Kotlin unless you use const and stuff like that. So it's like kind of, it's a place in the source printer that I haven't dealt with. So we'll probably just go real quick to add that. So I'm gonna open up the source printer here. And then this is probably in like visit field. Yeah. So I'm just gonna set a breakpoint right there. And I'm guessing what I'll do is I'll just put like if it's static, then I'll add the static keyword to the front of it, just so that that's represented in the result. By the way, while this builds, I'm just gonna go get some water real quick. So I'll be right back. Okay, we're back. If we all give suggestions to Leland and he writes it all, does that mean we have all contributed to the Compose compiler? I think so. I think that's what that means. Okay. Interesting. This did not hit that breakpoint. Kind of surprised. Visit field. Now. So maybe it's just a property that it's hitting. What is this? Class for each property. Value parameter. That's different. I don't think it's hitting that. Okay, let's try running it again, see if it hits on one of those. Just a general question to the people listening in. Has everyone been following this all right? Is this like I know I spent a lot of time kind of explaining some things before we started coding, but I'm curious. I don't know how in this are people. Do you feel like you understand everything that's going on? I hope that you do, but just curious. Okay, so we're inside here. So it's inside field, so I wonder why this didn't hit the breakpoint before. Maybe because of this if or something, I'm not sure. So basically here is static is true, which is what we expect, but we aren't using that information anymore because it's like not a normal Kotlin thing. So what I'm gonna do is just say if declaration is static, and in that case, we're gonna add static to the front of it. That should be enough. We just want to make sure that it's represented in the result of our test. So I'm gonna do that, and we'll see what happens then. Do I want it to be const? I guess we could consider it const. I don't know. I mean, I kind of want, because const means a specific thing in Kotlin, and so like the result here, I want it to be human readable and understandable, but I'm not sure that. I think maybe I'll keep it static just because that's like a very specific thing for the field itself. That's cool to hear, Danny, that you just had me kind of going in the background. That I don't know. I like that. I like the idea of of that. It's kind of cool. One of the reasons I'm like doing this whole Twitch thing is just I don't know, because of the social interaction. I think it's a neat new format for content. And so it's cool for me to hear that people like you just kind of have me going in the background. Makes me feel good. So okay, so now we've got it printing out kind of what we expect here. And so the next thing I want to do is I want to give it a value. All feels like magic. Yeah. So let's see if we can do that. I think, I'm not sure if there's a way for me to build an initializer here. I'm gonna say initializer. I'm gonna grab that. I do something similar in live literals, so I'm gonna just grab that code real quick. So should I set the parent? Expression body. Okay, I think that'll be fine. Let's actually, okay, so let's go back to what we had. And then I'll go ahead and do that. Just to keep it as one expression. And then this is going to be undefined again. And this is just going to be higher const. And then like basically let's just set this to 1 right now, and that's not actually what we want, but just to make sure that it shows up correctly. And go ahead and run that. Probably said it before and we'll say it again. Having a Google engineer in the background is quite something new. Don't sweat it. This particular video is compiler internal, so that's okay. There was some explanation in Q&A, and that, yeah, yeah, definitely. I mean, that's something important that I want people tuning in and seeing this. I hope people don't see this and think like, oh my gosh, this is what I must need to know in order to know compose, and that's not the intention at all. So this particular series, so the streams that I'm doing on Wednesday and Fridays, these will be me working on the compiler, and that is like not needed to know compose at all. And so, you know, if this type of stuff isn't interesting to you, or if it's not, if it's just hard to follow, or like, you know, not interesting or anything like that, feel free to ignore those streams. Thanks. Yeah, I'm glad you're enjoying the content. Okay. All right, so we added the initial value, and that showed up correctly here. So that's a good first test, right? So like we're adding some constant and behaves like we expect. So I think now like this is a good basic case here. Let's just say test var versus this val property, single var versus val property. So basically here what I'm thinking is I'll have like foo val var int, and then I'll just call this should be stable and this should be unstable, and so I'll just change this from val to var, and then the result here should be stable val bar int and unstable bar. So I mean, I'm just kind of going through like the really simple cases for stability, which you know, having a mutable property will kind of immediately opt you out of stability, I think. So this is a good base case. And let's see. Okay, so we're actually using the value of 0 to indicate stability. So this one will actually be 0, and this one will be 0. And then this one should actually end up being this 2, 3, 0. So what this is it's that the first, so this is basically, it's meant to be in the same format that the changed parameter is in. And so the first bit is reserved for that like force execute, and then the next 3 are for that first parameter slot. And so there is no parameter slot here, but what we're gonna do is we're just gonna reserve, we're gonna think of this constant as like that first parameter slot. And so I'm gonna put it there. You restrain this. Wait, make the test green first. Make the test green first. So I did, kind of. It doesn't show it here, but I basically, it's, you know, kind of like a golden file, and I just copy and pasted it here because it's what I expected it to be. Right now it'll return a 1, so this test isn't quite green, but I'm gonna change that in a second. So we'll see what that's like. Let's just go ahead and define. Well, actually, let's go back into our function body transformer, and in here we've got like param state. So we've got this enum, and so what I'm gonna do is I'm actually gonna start changing some of these things and then create that enum. So let's see, to do that, so uncertain is going to be that. Actually, we should think about whether or not we want to do this. I think I might keep this class here. Like, if you think about it, we're now encoding. We're encoding sort of 2 separate pieces of information into these bits. So like we're encoding the stability, and we're encoding the like comparison state. And so I think I might rename this class to comparison state instead of param state, and then have a separate sort of thing just for stability and like a way to calculate this separately. I think that'll end up making the code easier. We'll just have a separate thing here. I think to start, let's just define a top level constant. I don't know. So unstable will be that, and val stable. Stable flag. Let's just, well, okay, let's create an enum. So enum class stability. Yeah. And we'll val bits. We'll do something like that, and then have unstable, which will be this. Yeah, I think so. And then stable, and then this will be, it's just 0, but just to be consistent with this, I'm gonna keep it like that. And then what I'm gonna do is I'm gonna say bits for slot. What did I call it over here? Yeah. Do something like that. So then this is like the slot index. And then what we want to do, so this will end up being, it'll be bits. And so I'm shifting it 1 for the force, the bottom bit, which is like the force update thing, and then plus the slots, and each slot is gonna get three bits. So then this should be good. Yeah, Chuck says consider unknown instead of unstable because we've not proven unstable. Yeah, that's a good idea. I'll do that. Thanks, Chuck. Stream code review. This is much better than just waiting for you to comment on my CL about it. Like in this way, you know, I can push a CL and you can just +2 it immediately because, you know, you've already seen it. Should stable be 1000? So it would make me feel a little bit better if it was, but I think I forget why I figured this out the other day, but I think that some of the bit manipulation ends up easier if stable is 0. So I'm gonna keep it 0. I think that will be better in the end, but it's a toss-up. All right, and so now what we're gonna do is like yeah, let's just say we had some, like, let's say we had like some boolean is stable, then what this will end up being is if is stable, then stability dot stable dot bits for slot, and then it's always going to be the 0th slot that we define for this like stability constant, It's always going to be the 0th slot. Dot unknown dot bits per slot. And so we might end up tracking, instead of just is stable true, we might end up tracking a stability enum. I'm not sure though, because I think it might be easier to have it be a Boolean. I don't know. We'll see. We don't do that here. Yeah, no Java here. Oh, so that creates an int, but I need a constant. So just put that in a constant, or I need an IR expression. That's what I need. Okay. So now what we want to do is like we kind of want let's see, when we visit the class, we kind of want to have some object that we can manipulate as like the current class, and we'll use that object to know after we visit the class whether or not it's stable or not. And we can have nested classes. So I think what we're gonna end up doing like a stack type thing. I think that'll be a pretty reasonable way to do this, I think. So let's create this object. So like class stable class stability inference state. Chuck's gonna make fun of me. I can feel it. Something like that. We'll do that. So this will be, we'll get one of these, and let's create a stack. State stack. This is nullable, and so the getter is just gonna receive the current one. So state stack. This is probably length size -1. So it's just getting the top value. Good. And so then inside here, let's say we'll wrap this in a try. And we'll have like a previous state. Or we don't actually need the previous. We just need to push and then pop. add, and then here we'll say stability inference state. And then here we're gonna pop it from the end. Remove at state stack dot size -1. Yeah, let's see how that goes. Oh no, what a... I think I missed some chat. What's happening? Replace that if else with win for the look. Yeah. True. Extract to a method. What do you think? This is the thing we should extract? I don't know. It seems fine so far. It's not that big. We'll be tweaking this code a lot. Latency is so high. Lewis, are you saying that the latency between like what when I see a comment versus when you see it, or what do you mean? Yeah, DevSusa, I mean, this is it is one of the nice things about this being open source, is that I can do something like this. I'm pretty happy about that. I'd like working on Compose to be my day job. Yeah, apply to Google. How do you make the also look different? Yeah, these I don't know if this is a ligature or if that's just what the L looks like. Oh no, yeah, you're right. I don't know how that works. I'm not sure I understand ligatures in fonts, but it seems to do this kind of thing for some things and then not others. So I don't know how that works. Someone can let me know. It is really cool. I like ligatures a lot, but I don't know how they work. Okay. Oh, is it just that it's italic? Yeah, that makes sense. Okay. Good point. Okay, so now we've got this current class that we can use, and so whenever this gets called, the current class is going to return this, and so then we can use that to basically, you know, store some information. State this. But now, instead of is stable, we can say like inference state is stable. Right, so now we can go here. We can say inference state that is stable. We can have base it off that. And so now just to get our test to pass, we can do some pretty simple stuff here. So we can say override fun visit field. Trying to think if that's what if I want to use field versus property. I'm not sure yet, because we can get to the property based on this. So if equation.is var corresponding property symbol is var, no? Oh, owner dot is var. So this is not careful logic or anything, but I mean this will get our test to pass, right? So is stable. I wonder if I should to make the nullability of this different. Maybe I should have like just some like top level inference state thing that I don't use. I'm gonna try that. So let's just say e equals stability. Guess I can't do that. I'll d let's call that top level. So then here I can initialize it with that. So stability. Actually, maybe the safer thing to do is to do this. So now I can get rid of that nullability. Oh, is this gonna? Guess I'll use get instead. Why is it? Oh, will this give me an exception? Oh yeah, well, okay. All right, maybe I'll do the other thing then. Do that. And then this can be an indexer. And then I'll do that. I mean, technically, if I had unbalanced try catches or something, then I could end up popping this and get into a bad state, but it's not gonna happen. So I think I'm fine with that. So then we can say is stable false here. So if we run into a var property, then it's false. Oh, get or null. Yeah, it's I'm alright with this right now. Test leaks. The first hour almost of this stream kind of goes over a lot of what we're doing, why, and what some of these concepts are and stuff like that. So for the benefit of everyone else, I'm gonna say go check that out if you want definitions on these things. But appreciate you coming by. Okay, so I think with this, these tests might pass. So let's just go ahead and try that out, see what happens. Looks a little with ASM API. I'm not exactly sure what you mean, but the I will say that this is much cleaner to work with than the ASM API. I think, at least my opinion. All right, so going back to our tasks, one of them failed. So let's see what it did. Oh, well, actually, it kind of did what we expect, but it didn't use this binary representation here. So the result is just 8. Which is the value that we're actually, it's not the value we're looking for, because we wanted this to be and so that should be 16, not 8. So I think I've got I think I've got a bug in my bits for slot thing. Oh, I know what it is actually. So is it possible to print OB1000 instead? Kind of. The problem is that then if I write some code that's like, 1, 2, 3 or something, I don't really want it to print out the binary representation of just every int in the entire source file. So what I actually started doing, and you can see this in some of the other files. Let me pull it up. So if you look at some of these other tests, you can see that it prints out the binary in a lot of cases. And I kind of inserted some logic into the printer to do that when it can tell it's like a binary thing. So like one of the things is like if it's an argument to and or, then I start printing in this format. But for this, we're just in the initializer of a field, and so I don't know if I can easily do that. Let's see. All tree-based IRs look somewhat similar, yeah. The main annoyance for me was that many things are retrieved by reference, while in the ASM API you could just define a method as a signature string. Yeah, I mean I think it's a lot easier to get ASM to do something. It'll it's not as checked or anything like that. And so it's very string based, and so you can just tell it what you want, and it's not difficult. But I think producing like valid code in ASM is a lot harder to do. So I don't know. It's a trade-off, but I'm happy that we went with an IR transform. Crying in serialized IR. I haven't used ASM, but a bit of Java assist. You can indeed just write bytecode with mere descriptors, but it's too low level, hard to work with. Yeah, that's kind of how I feel about ASM. Okay, so I'm pretty sure that 8 is wrong. So let's see, what am I doing wrong here? So I've got the bits. I pass in 0 here, and so I'm shifting this left 1. Should work, right? Let's just write a quick test for this because now I'm second guessing myself. Bits for slot. Equals. So let's just say that stability that unknown bits for slot 0. And then I have like a nice printer here, so binary and usages. Where's this? I'm gonna take this and make it a top level function so I can test it independently, or use it in tests rather. So, oh, it's actually a different module. So, I guess I'm not going to use internal. There we go. And so, basically, I want this to be this. Let's make sure that happens. And then I want 1, 2, 3. I want that to be that. So let's find out why that's happening. 16 is, oh. Okay. Yeah. All right, well, it just turns out that I'm not very good at reading binary, you know? So you can't hold that against me too much. All right, so there's no bug in my code, but anyway, this will be a good test for us anyway, so. Is that right? Expected, oh, right. So, the binary string printer that I have, it prints 1 byte at a time. So, so it's gonna do 2 bytes for this one. So that's why that showed up. But that should now pass, and this is working appropriately. So. No bugs, just me not knowing binary. Now I need to fix byte printer. Okay. So this is neat. This is a pretty good start, actually. I'm actually, I think what I want to do, because like so going into all of the inference work here, It's like it's gonna be building out the inferencing is gonna be a decent chunk of work, and I want to be pretty precise about it, but I kind of want to get everything set up first. So I think the next thing that I want to get working, because now we have it adding like a constant and stuff like that. The next thing I want to get working is I want to figure out how to reference it across modules, as well as in modules. And so now I'm going to start working on the actual like function body transformer. Ursus, if you're asking about my chair, I have an Aeron. That's easy to see. I'm not sure what an embody is, but compilers are an enigma to me. Yeah, me too. Okay, so yeah, this is kind of a good start. So I think let's go to the function body transformer now. Oh, it's another Herman Miller chair. Is that the like super? There is some. Let me look up a picture. Miller, what is it? Embody. Yeah, I think this is it. So a coworker used to have one of these. Man, these are nice chairs. They're expensive. I would love to get one of these chairs. Yeah, they look pretty cool from the back as well. Anyway, I don't have one of those. Yeah, they're expensive chairs. But, you know, I sit in this chair too many hours a week. So, you know, it's justifiable in some ways. Okay. So let's go to the function body transformer. Actually, let me show you some of the tests. So this is the function body skipping transform tests. Which, by the way, like if anyone wants to work on the compiler, or if you want to understand more about like what the code is that the compiler is generating, pulling down, like this is a good way to kind of go learn more or like test your intuition, and you can write little tests like that. You can basically say like, okay, if I write code like this, what's the result gonna look like? And you know, sometimes it's pretty sizable. So anyway, that, and it might test your intuition or show you if something weird's going on. But this like test suite is it's a cool way to kind of learn about what the compiler is actually doing. So what I'm gonna do, I'm gonna start kind of eating at this transformer to change the encoding to 3 bits instead of 2, and so that's gonna take a little bit, but we'll go ahead and start down that path. Yeah, we could open source the source. I mean, technically it already is open source. It's out there, but it's not easy to get at. But yeah, I wouldn't have a problem with that. Is the test suite built by the compiler devs too, or is it part of some testing kit by? So the source printer and stuff, like a lot of the testing tools, I built myself, like that source printer and stuff like that. JetBrains does have like some nice testing utilities that you can pull down, but we don't use a lot of them because some of it's not all that useful for us. But like we have there's some, let me pull up an example here. Where are some of these diagnostic tests that we use? What am I thinking of? I'm thinking I'm at like a loss. Is it in a different file? Oh, it's in this file. Okay. So for instance, we've got like some tests here, like the compose compiler will do some analysis on the front end. So like it'll check some things like if you're calling a composable function from outside of a composable function, like we'll issue a diagnostic in that case. And so this diagnostic test uses some of JetBrains utilities, like the top-down analyzer facade for JVM. This is like something built by JetBrains, and so we're using that and some other things, but we kind of build a little bit on top of their utilities, and so what this does is like it allows us we can write tests like this. So like you can just write some source code, and then we can put these little indications here, which basically this indicates that there will be a red squiggly, you know, like error underneath C and stuff like that. We do some things like that. What does it say? So foundation or testing was reported some testing. Yeah. So Danny, the front end, this is a way to kind of refer to the part of the compiler that basically parses the source code and then runs type checking on it. Like you can kind of say, okay, it's the type checker part of the compiler. Something like that would be a simple way to think of it. So like commonly compilers, you can think of the front end and the back end. So there's like the front end that does all the type checking and like basically attaches information to the source code and builds up some in-memory representation of that. And then the back end takes that and then generates whatever artifact you're generating, like in our case, class files. And so most of the compose compiler works on the back end, but we do a few things on the front end just to like give you compile time, or sorry, to give you like IDE time errors and stuff like that. It's what hangs your IDE. Yeah. So in your IDE, you're running the front end of the compiler all the time, but not the back end. Okay. So bits print is gonna stay. So we want to change slots per int to be 10. So so in this case, this 2 here represents the, maybe it's probably a good idea to pull this out into a constant. So bits per slot. And so previously that was 2. I'm gonna change it to 3. Let's go ahead and do that. And then maybe a better way to calculate slots per int would be, you know, the floor of bits per int divided by bits per slot. I don't really care at the moment to be that pedantic, but have you seen this project before? Kotlin compile testing. What is this? In-process compilation of Kotlin and Java code. I'm not sure this would be useful for us. Asserts process. I guess you can add annotation processors to this. That seems nice. I'm not sure it'd be useful to us though. We use it for testing annotation processors. Okay, yeah. Useful if you want to run some code. Applies the plugin and compile sources you want. Yeah, I mean that's pretty cool. That's like a, I mean, this certainly seems like a nicer API than a lot of like the APIs we use. Yeah, cool, yeah. Yeah, I mean, we do some of the same stuff. So, like right now, we're not actually, the tests that I've shown you, we're not generating, bytecode, but some of our tests are. So we have, let's see, what's a good example of one of these tests? So in here we're actually like running code and stressing the runtime. So we have some test utilities that like it'll actually run compose with this code, and then we get back the activity and we can like, you know, find the view by ID and perform clicks and stuff like that. So we've got a lot of code that does that type of stuff, and the way we do this is it's code that looks kind of similar to this like to this thing. It's just maybe it's a little bit more complicated in like a not good way. It's like uglier code, I would say. This looks pretty clean. So maybe too high level. Compose might want to check individual transforms. Yeah, I mean, but like, so for this type of testing, it's kind of like what we're doing. We're basically just, it's more of an integration test where we compile the whole thing and like we start running it with the runtime and stuff like that. So it's definitely, it would still be useful if we weren't already kind of doing the same thing, just with like less clean APIs. Okay, so one of the things that we need to change is the where is it? So this stuff. So in this expression here, where we do this like weird XOR thing, the constants that we generate here are going to be different. So let's go update that. I need to remember where that is generated. Is so build statement for so can skip execution, should execute. So this is where we do that. So we say IR has differences on this thing. So this is a changed bitmask value, which is a class I created. So in here, so this is where we generate that constant. So Andre says from the JB side, they usually unit test lowerings with just IR bytecode dumps. Yeah, they do. Yeah, I think maybe they've improved it. But when I saw how they were testing the IR, it seemed like they were doing the like everything and then just looking at the produced bytecode with like bytecode golden files. And the problem with that for so for them that might make some sense because they're testing the compiler as a whole. And so for them, unit testing each lowering is definitely like, I mean, something that they could do, but it might not be as valuable as like the integration test of all of the lowerings. But the problem with that is that from our perspective, every time, if we just looked at the raw bytecode, then our tests would fail every time we upgraded Kotlin because they might change the lowerings and stuff like that. And so, as far as we're concerned, how they lower IR is like an implementation detail of Kotlin, and we just want to test what IR we produce. And so the IR source printer seemed like a much saner way to test our transform and like actually be able to see kind of what it's doing. So but I mean, if you want to talk to me later offline about open sourcing the source printer or something, like I wouldn't have any problem with maybe publishing it as a separate artifact, or we can figure out how to do that. But some of it is compose specific at the moment. All right, so what are we doing here? So in the case there are no parameters, you can create a shortcut expression of just checking the low bit for non-zero. Yeah, okay, so this isn't going to change. This is going to stay the same. So then when we have parameters, we go through each one. And we might have multiple changed parameters. Think an int with each slot having 0, 1, all of it being 0. Yeah. So this creates an actual int with this, and bits for slot. And then, yeah. So in this case, what we're gonna do instead, so basically we used to just do like 0, 1, 0, 1, XOR 0, 1, 0, 1. And then like this was 1 and then this was 0. But now what we're gonna do is we're doing 1, 0, 1, 1, 0, 1, 1, XOR 0, 0, 1, 0, 0, 1, 0. And so now this whole thing is different than this whole thing. So we're just gonna create two different ints here instead. So let's just say let's call this where's my rename? There it is. So let's just call that left-hand side, and then right-hand side. We'll just do the same thing. So this was 1, 0, 1, and then now we're doing 0, 0, 1. Open sourcing the source printer would be great. Interesting that you're using it in your own project. What Ivian, if you don't mind me asking, what is it that you work on? And then a hacker, yes, this is open source. This is the Compose compiler. It's part of AOSP at the moment. By the way, maybe I should mention this, but if you go to cs.android.com, you can find all of this stuff. So function body transformer. So like for instance, this is it. In this, if you don't know about this, cs.android.com is like CS stands for code search. This is a really great tool, and it's a good way to browse through code. So definitely check that out. Yeah, all that stuff's here. So. All right, so we've got this like left and right hand side. And so we're gonna and the param with the left hand side, and then XOR it with the right hand side. And I think that's all we need to do there. And what else do we need to do? So we need to update this in places. So like, so one of the things that the compiler does is like when you call a composable function and then it passes in the composer, and then this dirty flag, it'll it'll create some expression here if the parameters you passed in are just like blanket passed in from above. So one of the things it needs to do is like figure out which, whoops, it needs to shift that bit pattern over to the corresponding parameter. And so I need to update where I calculate that. Where is that? Trying to remember what the name of the function is that I called it. Build changed param for call. That's what I'm looking for. Let's go there. Okay, yeah. So this is like basically what we do. So like here's the mass parameter, and then we like grab the bits out of some slot, and then we shift them to map to the other slot. And so the way we calculate that is gonna involve this sort of bits per slot number. So we use bits per slot. But where do I shift it? It's a DI compiler plugin. I use the source. Oh, this is what you're working on. Oh, cool. What's the compiler plugin? Is it open source, or is it like for an internal thing that you're doing? I'm trying to find out where I do the shift. Oh, here we go. Okay. So I probably need to update this implementation. All right, so this is the 2 that previously would like represented this. So bits per slot is what we want. And that's probably all we need to update. Let me just see if should I look. There's gonna be a lot of 2s in here that have nothing to do with what I'm doing. Just gonna see if I use the constant 2 anywhere that looks suspicious. Record source parameter. I don't think that. Yeah, that's fine. Okay. Yeah, that might be the majority of what we need to do. We also need to, in the composable lambda implementation, we're gonna need to update some of this. Okay, so here we use bits for slot. Let's just update this. Slots per int, bits per slot. So we'll update this to 10, and then this to 3 again. So same bits, different bits, that still works. Right, yeah, so stable versions stay the same. Ooh, all this is gonna have to change. Okay. So this is kind of interesting. Might be interesting to some of you. So we transform lambdas into this composable lambda implementation, and it's a class, but it actually implements like all of these different function interfaces. But it's kind of interesting because once you get to a certain number, so previously we had 15, when we could only hold 15 bits, or like 15 slots in the single changed int. So when we had 15 non-synthetic parameters, as it actually implemented function 17. And then as soon as you jump to 16 non-synthetic parameters, we jump from function 17 to function 19, because then we jump up to 2 ints. And so that's all gonna change a little bit. So now, here's the compose compiler source. Oh, yeah, thank you. So now, once we go above 10, that's when we're gonna jump up to 2 int parameters. So we're gonna go from function 12 to function 14 when we go from 10 to 11 parameters. And that should be the only jump that we need to deal with. This is the GitHub link for my plugin. Cool, let's check it out. Oh, inject. I think I've heard of this. Oh, Andre, you contribute to this as well. Okay. They're reading me only. Okay. So initialize inject indicates that this module is forwarded, records file where initialization happens. Reader annotation. Given. It's a little out of date. Okay. Anyway, this is cool. I'm always interested in people building Kotlin compiler plugins, especially ones that target the IR and stuff. I kind of think that compiler plugins kind of an interesting alternative to annotation processors, and I don't know. I wonder if there could be a future where that's sort of the primary method of annotation processing, but I don't know. Anyway, really cool. Thanks for sharing. Okay, so we do this jump here, and then we probably won't do any more. So let's see, we've got 14, 15. 16. So 18 formal parameters were fine. And then why is this hard for me to grok? Okay, so we just up all of these by 1. 7. And then we're good. Okay. See if any of these implementations need to change. I don't think they will, because we were just using the bits for slots and stuff like that. So different bits. Yeah, these seem fine. Right? Different bits for... Yeah. Wait, what are we doing here? Oh, interesting. So do we need to change this? What are we doing? When we invoke a lambda, we create the dirty parameter. And this is for the this parameter. I see. Okay, so what did we put in? Oh, I see. Because this is for... Ooh. Front bits. Okay. Wait, did I do this wrong then? Is this not... the right? Wonder if we need to do it at 9 parameters instead. What did we do before? Wonder if that was a lingering bug. So for P15, when we used to implement this, we did it for slot 15. I think this was a bug. Because what's happening... So what's happening is this lambda has... it's got 15 parameters to it. And so before we could store up to 15 parameters per int. But we want to treat this value, like, so the lambda itself, as one of the parameters. It's like a implicit parameter. And so that would make it the 16th value. So this is different bits 15. Like this is gonna be wrong, I think. So if you went and looked at bits for slot 15, like you're shifting you're shifting these bit, like, so this is like gonna be like an overflow or something. Okay. So I think this was a bug before. I should maybe fix that independently. I'm just gonna fix it here anyway. I hope I'm not wrong about this. But okay, so that means we can go up to 9 formal parameters on the single int. And then this one is gonna get the 2 ints. 2, that's gonna be 13 then. All right, and then the last one we do is 18, which just happens to be the last one that'll fit on 2, so that's fine. Okay, so now when we first hit E9, that'll be valid. I don't need to change that, but we do something different here. So what did I do down here? Just called it changed 1. It's fine. So we'll say changed 1 int. And then we actually C dot changed. I wonder, this is dirty 1 equals changed. I think we want to, oh, I guess, yeah, changed dirty. I think that's fine. But this needs to be changed 1. And then this will do the right thing because I do modulo, yeah, or rem. Okay. What is that complaining about? Oh, I didn't. Wait, cause okay, 9 and then 10 is when it has 2. P10. So this is changed and changed 1 int. There we go. All right. And then here we want to pass in the original changed, not dirty. Okay. So that's our general formula for the remaining ones. We need to, okay, add a changed 1. I'm just gonna do that for the remaining ones. Okay, and this one's already got it. So, okay. Then okay, so this will be that. And then I want to call changed. Did I do that right on the first one? Changed and then changed one. Yeah, okay, I did that right. And then change the type. Looks good. And then changed one. So this will be changed one. And then changed one. Or no, changed. Okay. Changed one. So yeah, I'm guessing anyone who is watching is probably wondering what the hell this class is used for. I mean, it's kind of crazy, but we just so every lambda, every composable lambda is restartable. So we can use like the lambda itself as a scope to start recomposing. And there's just some machinery that we normally generate for functions, like in the body of the function. And for lambdas, what we ended up doing was just we just created a class that does a lot of that, and so then the body of the lambda is lighter weight. And it also allows us to do some nifty things, because then like we have this like update scope lambda that we normally create in composable functions. But for composable lambdas, sometimes we can just use the lambda itself as the restart lambda, and so that then avoids some allocations and stuff like that. So it's pretty clever, but it results in this like kind of gnarly class that just needs like every arity of the function needs to be defined. Changed. Okay. What's it complaining about there? It's weird that it's complaining about that one, not any of the other ones. Why? Why is it doing that? Oh, I see. Because this, we don't implement this anymore. I'm confused about why this is calling this an unchecked cast now. Or aren't they all unchecked casts? Like, why wouldn't this be? All right, I don't know. I'm confused, but we'll see. See what happens. See, so this needs to be changed 1 again. Changed 1. Changed. Last one. Changed 1. And then changed. Okay. So now all of these are getting, oh no, it's still just this one. All right. I don't know why, but now I'm just gonna go fix some of the formatting for, oh, do I need to go through these though and fix this bug? Changed 1, no, that's done correctly. Okay. So just gonna update this formatting. Okay. We got a few of them. This is the unglamorous part of programming. Okay, that one just went yellow, so I think the analysis of IntelliJ is just like lagging behind and doesn't know. I don't know. That's what I'm gonna convince myself of. Although now it just disappeared again. All right. I'm at a loss. If someone sees what happened here that is causing it to be unhappy, let me know. I don't see it. What would this be? This is the P15. Yeah, I don't know. Okay. Oh, that is good to know. What Grand Station? What is it? Oh, I guess I just do like an Alt Enter thing. Is that? Put arguments on separate lines. Okay. Yeah, that would have been good. Thank you. Function 12. Oh. Oh no, that's the one. So basically, we can only fit 10 parameters in the bit mask that we provide. So when there are 9 non-synthetic parameters, That's 9 plus 1 for this parameter. And so that means that for function 11, that int is like fully filled out. So when we step up to 10 parameters, then all of a sudden we need 2 of these bit masks, which means that the interface jumps from function 11 to function 13. Yeah. Okay. I think that's good for that. I think we also are going to need to update. There's also composable lambda n, which is like the equivalent to function n. Ugh, this class is very red. I don't know why it's red right now. Const val slot bits per slot. So I think I used that in a few places here. Oh yeah, this is gnarly, this calculation here. I guess that should still work when I update it to 10. So we hope. Okay, so this is our like function n interface, and we've got to fix a few of these things here. And apparently the IDE is all messed up, so we're not gonna have any IDE help. Okay. Different bits, real params. Yeah, okay. Last change, so I'm doing that right. Changed n. Real params. Does this all make sense? I am not sure. So where did... I guess everything is just sealed into this calculation, I think. Okay. And so since I'm using this different bits function again, which that is what's going to end up having this like bits per slot usage. So I actually don't think I need to update anything but this here in this file. I think we're good. Okay. So let's run a few tests and see what this looks like. Skipping transform tests. So if we did everything right, almost all of these tests should fail. Let's find out. But they should fail in a very particular way, which is what we're looking for. I think after we see these tests run and what the results are, I think I'm gonna sign off here. We've gone pretty long actually. This was gonna be 2 hours. But I felt like we were in a pretty good groove, so I went almost 4. So it's been 3 hours 45 minutes. And I think for this kind of work, that kind of makes sense. It's like I'm just kind of, doing my day to day. So hopefully y'all still found that interesting. But I think it was easier to do a longer stream here, so maybe I'll do that. We'll see. So waiting for the build. One of the things to note is like when I update some of the runtime. So in this case, the Lambda class that we just worked on, this is in the runtime. So if you look at this, this is part of the runtime module. And so we have this like kind of weird dependency graph between the compiler plugin and the runtime and all this stuff. So whenever I change some of the runtime, we kind of almost have to rebuild the world. And so this build is gonna take a while, actually. Now would be a good time if anyone has any questions. To answer some. The average build time for the compiler. I mean, if we're just changing something in the compiler, it's not that bad. I haven't looked at it, and I don't think we're even tracking it, but I think it's probably something like 15 seconds or something like that. Like it's not that long. If you're just changing the compiler, but when you change the big thing, it's pretty bad. Changing the runtime quite quick. Andre, what do you mean? Did you like you changed something in the runtime and then you ran some tests and it was actually really quick? Too many times. Gosh, I forget that you like actually work on this stuff. We need to talk more. I feel like some of the stuff you're working on is really cool. 30 seconds. That's interesting. I feel like well, it might depend. I don't know. Did you change any of the Gradle files or something? Yeah. Because I think right now it's not only when you change it, like, so if you look, let me see the compiler integration.gradle. Let me find this. So if you look at, this is the build.gradle for our tests. And you can see that we actually rebuild the entire Compose UI project. Just because we end up, you could debate whether or not this is like a good idea or not, but we end up exercising a lot of the Compose UI code in our tests for the compiler. And so, I mean, this kind of ends up as like a integration test on its own, where like if we can compile all of Compose UI, then then we're doing something right. Oh yeah, if you're doing the JS things, yeah. Yeah, that makes sense. You could have had a different. It was like just doing the It wasn't doing any of the JVM depths. I don't know. Yeah, this is just really cool to me that I can stream what I'm working on. I don't know. It's fine. I've been kind of wanting to do this for a while, and I feel like it's going pretty well. So I'm excited about it. So as we're waiting for this test, I think I just realized that it's not going to do anything because, well, no, actually it should. It'll still do something. It'll change all of the slots. Now will have 3 bits, but none of the like stability stuff that we did is going to be included in this. So Ivan asks, how do you plan to access the stability field in other compilations? That'll be one of the things that like I'm wanting to like figure out exactly how that'll work, but I think I'll in the back end I'll still be able to get the descriptor of the class and then go through its member scope, and I think that it'll show up there, but I'm not entirely sure. That's one of the problems that we're gonna have to figure out, like go through. Paid by Google and Twitch at the same time. So I don't plan on taking or asking for any money on this stream. I don't know. I have no problem with people that do. I just don't think it's what I want to do. So I'm not gonna be doing that. Yeah, the descriptors. That's true. We probably shouldn't use a descriptor. I don't know. We'll figure it out. That'll be the next challenge, is how to access the stability field. I'm sure there'll be some way, but it might be challenging. So let's see what changed in some of these. So let's pick like a simple test. What is a simple test? Is not. These are big tests. Our test naming is not great. Okay, so yeah, I don't know. This is a pretty small test. Let's just go and see what happened here. So find it. Okay. Guess this is kind of predictable, but the only thing that changed was like the XOR thing. So this line changed, and now we're generating 1011 instead of 0011, which is what we wanted. And so none of these are going to change because the binary representation of this, even though we're using an extra slot, isn't going to change at all. So we should probably look at a more complicated test than that. But still, well, I don't know. Yeah, okay, let's just look at a big one. So simple box. Let's see what. So we can see here the things that changed. So this changed a bit. And so this is kind of predictable. So like this is the second parameter. So this is the children parameter, which is the second parameter. It's a simple box. And the bits to pull out the value or the state of changed shifted over by 1, which is what we want. But we actually, this is an error because what we wanted was we want to pull out all 3 of these bits instead of just 2 of them. Or actually, this is, oh, so that's what it was before. So what we want is we want all 3 of those characters to be 1 instead of just those 2. So this isn't correct yet, but we're on the right path. Let's see this. So that looks correct. So before it was, 0 1 0 1, and then now it's 1 0 1 1 0 1, and so that's correct. And then this changed. What is this? Oh, this is the body of the lambda. Okay, yeah, so that's fine. Okay. So anyway, I mean, it looks like we're on the right path. There's still some bugs here, but I think that'll probably be a good stopping point. From your experience, the field shouldn't be there. How do you plan to access the stability field? Oh, I see. You're saying that you don't think because it's a field generated in the back end, you think that it'll be difficult, or like that we won't be able to see it from the compilation. That might be true, but I think so if it is true, then my backup plan is I think that we'll be able to add some information into the metadata of the class when we generate it with the compiler. And so I think we'll be able to get around it that way. Dustin says, thanks for doing this stream. Huge step for the community, transparency. Yeah, I appreciate that, Dustin. I'm a big fan of transparency, so I like that we're moving in that direction, and I think it's really cool. So thanks. Okay, well, that's gonna be it for today. I will be working on this more and streaming it on Friday. That'll be the next the next stream I'm doing, and it'll be same time on Friday, I think. And so if this was interesting to you, come check it out. And as always, appreciate all of you watching. Really happy about this. Thanks. Don't forget to drink water. I've been trying. I've gone through 3 glasses. Yeah, I hope some of you did learn some things. So cool. All right. Thanks, everyone.